I'm Jim Gettys. I work for Digital Equipment Corporation at the Cambridge Research Lab in Cambridge, Massachusetts. And I'm here to talk about the X window system and maybe some of the scars and arrows of outrageous misfortune we learned along the way to building X. I hope you all find it useful and entertaining. In any case, X started quite a while ago in 1984, and we initially, when I say we, Bob Scheifler at the Laboratory for Computer Science and myself needed a window system for our respective groups. Project Athena is a joint project. Between Digital, MIT, and IBM to further computer use in undergraduate education. So we started in 1984 with some software called W, which Paul Ascenti and Brian Reed had developed, and it very quickly became something other than W. Being very naive, we just continued down the alphabet and bound the free variable, which was a mistake. In any case, initial X development was relatively rapid and went through X version 10. The version numbers in X refer to the protocol version, which in fact defines when your applications break. X version 10 was more or less completed in 1985, and the first product was shipped by my own company, Digital, in February of 1986. And to our great embarrassment, X version 10 was too successful. That's the following spring, a lot of people started crawling out of the woodwork and saying we liked X, but, and then they fill in their favorite pet peeve, most of which we long since knew. And after sufficient arm twisting, Bob and I agreed to deal with heading up the design of X version 11, and we announced that to the public in the summer of 1986. X version 11, given the time constraints, since X version 10 was already becoming a commercial product, we had relatively little time to design and implement a replacement to fix the many problems we knew of from our earlier experience. And it was too much for us to consider doing directly at MIT. I proposed made a proposal to Digital Management to implement X version 11 mostly in Digital, and we implemented it and gave it back to MIT, where it formed the nucleus of the X version 11 distribution. In any case, the whole design was conducted completely in public. The specifications were put out for public review. We got many comments back from many people all over the world, and one of the world's larger alpha and beta tests occurred during 1987. I'd like to emphasize that many companies contributed in all areas of X version 11, to which we're all very grateful. And at this point in time, the future evolution of X is pretty well controlled by the MIT X Consortium, which is a group of, I don't even know how many companies at this point in time. And Bob Scheifler, my principal collaborator, is now the director of that consortium. Well, the first question we might raise is, why a network window system as opposed to a window system in which things may only run locally? From our point of view, this was quite important, in particular as people have gone from centralized time-sharing systems to individual machines. There's been a sort of schisming between people and their applications. It's been very difficult to build certain classes of applications which may need to interact with many users. For example, you may have a professor that wants to write an application, a gaming application that interacts with many different people's displays in the network. There are many good reasons. For example, your application may need to be near a database for best performance. When I mean near, I mean close in terms of where the data is stored. Again, not all applications may be available on your particular machine, so you'd really like to still be able to run your applications no matter where they are. So from our point of view, a network-based Windows system is clearly a useful thing. So you can arrange that applications can run in the most suitable environment for their execution without compromising where those applications are actually available. And from our point of view, X is just one of a number of distributed system services which should allow, with time, the engineering of seamless distributed systems, where I mean a user doesn't need to know or care where his applications are running. We certainly aren't there yet, but it's one of the fundamental tools that are required along with remote procedure call, naming services, authentication, authorization services, accounting, and so on, that one needs to be able to build this. So I think it's a step along the way toward that goal. So from our point of view, we may have an environment which includes many larger machines. They might be a compute server, in our case maybe a VAX 9000 or a Cray, or name your favorite large multiprocessor, in any case something more than you're likely to have in your desk. You may have many workstations of many different vendors, all the way down to something like a Macintosh, whatever. You may in fact be in a much more interesting environment, which may include wide area networks to yet more distant machines. So the large-scale environment in which you're working can in fact be very large. In any system design, there is usually a set of presumptions that one makes. They're often unstated, and it's interesting to think about them occasionally to understand where you're coming from, where you're going to. From our point of view, applications need to be able to run anywhere. Just restricting the run in your local machine is very boring. There are too many things my local machine may not be optimal for. Our design center, strangely enough, is sort of the modern campus scale network. Certainly that's the environment we were working in at MIT, where there are several thousand, well, at this point in time I don't know how many thousand, but there are thousands of machines on local area networks that are interconnected by various bridges and gateways. It turns out that in X, the interactive feel is often much more sensitive to latency than to bandwidth. Many applications run with relatively modest bandwidth requirements. However, latency comes back to haunt you again and again. We certainly do, and I'll hopefully be able to demonstrate later if the gods smile on us, run X over wide area networks. In general, due to latency characteristics, I wouldn't highly recommend running, I certainly wouldn't recommend running X applications over satellite connections. The latencies, they're getting awfully long for humans to tolerate the performance. We were presuming 1 MIP, 1 million instruction per second class machines. At this state, of course, even very inexpensive personal computers are considerably faster than this. Another presumption that was certainly safe from our point of view was that there would be adequate memory for off-screen storage of fonts and images. We were designing to a workstation model with virtual memory, and the X server does need a fair amount of memory for fonts and off-screen images that an application may require. Another presumption we made from the beginning was that we had to presume not just a single vendor's hardware. In particular, Project Athena was a joint project between Digital and IBM and MIT, so we knew we would be dealing with several different vendors' equipment, and certainly in the MIT environment there are also other operating systems that are in widespread use, for example on Lisp machines. We needed to deal with applications need to be able to be written in any language. That is to say, having a system which is too idiosyncratic to a given language would not be adequate given the diversity of the kinds of applications people were dealing with. Another presumption that we've made, and has certainly been borne out by history, is that good user interface design is still a very young field. From our point of view, it's really necessary to be able to support a wide range of user interfaces. We had to presume that not only would there be secretaries at one end of the spectrum, possibly, but at other ends of the spectrum would be computer science people interested in doing user interface design research, and professors who vary equally across all spectrum of expertise. A single user interface was not going to span that range of users, in our opinion, in any case. From our point of view, we also wanted to make sure that X was not making any presumptions unique to the network capability. X itself is an applications protocol based on top of a byte stream. Actually, let me go back for a second for a slide. So, in fact, what's happening is that X is ultimately really just a network protocol. It is a protocol connecting an application with a Windows system server which runs on each of the machines with the display, and that protocol is what X ultimately is. X is not in some sense, in the rigorous sense, a procedural interface. There can be many procedural interfaces to the same X protocol, but that protocol definition is the essence of what X is. It is a network protocol. It's happy to run over TCP/IP or DECnet or other networking protocols. Over the years, particularly the early years of X development, we determined, if you will, a set of guidelines to the development. I believe that most of them apply reasonably generally to systems design, and most of this talk will in fact be about systems design using X as an example. So this is sort of a summary of what the rest of the talk will be about. X itself is very much oriented toward providing basic mechanisms which can be exploited to implement many different user interfaces, many different styles, many different kinds of applications. And it attempts, to the extent possible, not to wire in a specific look and feel, to use the buzzword of the year, and to leave that to client applications to provide. Another major issue which comes up in large-scale system design is isolating complexity. You really want to keep complexity isolated into any complexity in your system, isolated into specific firewalled places, so that if something fails or dies, that it doesn't necessarily do you in completely, but possibly and probably more importantly, so that complexity doesn't come out and bother everything all the time. You really have to keep things isolated into small areas. Equally important can also be what problems you're really attempting to solve and what problems you're not going to attempt to solve. Another issue which came up was it was often the case that had we tried to solve problems immediately, we would not have had sufficient examples to understand what the problem really is. As in icebergs, most problems are under the water, where they're hidden, and it takes a while to understand the 90% under the water. In a related sense, obviously, you have to understand your problems completely. The 90%, 10% rule is basically just saying, if you can get most of what you want with a lot less work, go for the majority. It's a simplicity versus generality argument. That is to say, if you can get most of what you want with only 10% of the amount of work is usually the right thing to do rather than going for the absolutely full generality. Again, in large-scale systems design, you'd better worry about, in particular in distributed systems design, you'd better worry about how robust your system is. It's designed in, trying to retrofit it is a major problem. We've often made the statement, and I think it's true, X provides many mechanisms to implement different user interface styles rather than trying to define a single user interface style. Part of this is just that in all research that goes on in human factors often shows that there's a very wide range of experience and a very wide range of personal preferences. For example, occasional users may need a very simple, approachable style. On the other hand, somebody who uses a specific application for 6 or 8 hours a day is going to want to do nearly everything they can to make their job fast to run, even though that may require much more learning to be able to use the application effectively. Of course, don't use this as an excuse to avoid good user interface design. Some people attempt to do so, and I certainly don't agree with people who don't work hard on making their applications as usable as possible. In any case, there's obviously an awful lot of research to be done in user interfaces. So from our point of view, it was really vital that we provide a lot of powerful mechanisms capable of implementing many different styles of user interfaces. Another generic problem that comes up in any system is understanding whether something is really needed or not. One's wish lists are always of infinite length. There's always more than you can do in the time you have. From our point of view, particularly early in X version 11, we required that somebody be working on a real application and be basically stuck, unable to complete his application before we consider adding things to the basic X design. This helped a lot in keeping the wish list manageable, on determining what priorities of it. Of course, X version 11, being designed for a much larger audience, had a bigger problem. We, in some sense, for X11, relaxed the criterion to be knowing of existing applications that would require the functionality. At least 2D applications, we did limit the core X11 design to doing 2D graphics initially. Then in X, we attempted, or we learned early in X that it was possible to make most window management, by which I mean being able to move windows around, resize windows, those sorts of things. Let me actually give you a quick demonstration. If I have a terminal emulator here, moving it around in this particular window manager means picking the title bar and grabbing the window and moving it, or resizing it by the little resize box up here. So in any case, in X, all of this sort of decoration on the outside of the window, title bars, how you turn a window into an icon or not, how you move a window, resize it, those sorts of things are built into an independent program. It's not part of the base window system. This really cuts down on the possible interactions. If everything were built into the Windows System server, for example, you'd have a much higher probability of there being the combinatorial explosion problem between things that are interacting. So the interfaces between clients and window managers are reasonably narrow. There is a convention called the ICCCM, Inter-Client Communications Conventions, which allow applications to interact with each other and with the window manager. So right off the bat, X from basically the beginning attempts not to wire the policy of what window management looks like, and inside of applications we leave things to the applications themselves, and those are typically in toolkit libraries. This helps a lot in keeping as much as possible out of the Windows System Server. Note that this often allows a performance gain. This is not obvious to a lot of people when they first start working with things, but if your application takes a lot more compute than the graphics part of it, you'd be better off running your application on the faster machine across the network than on the local machine. So by keeping as much as possible out of the Windows System Server, this potentially allows this performance gain. It also obviously keeps the Windows System Server from becoming this huge unmanageable piece of code. Another basic problem that comes up is that people find it convenient to want to, if you will, abuse the X server and use it for things that it was never really intended to. X is not the world's remote procedure call system, for example, though I have certainly heard people in public claim that it ought to be. X is just one more tool in the suite of distributed system services we all need. So in X, what's going on is you have a Windows System Server. It is a single process. How it's implemented is left to the server implementer. The window manager is also a separate process. It uses, again, the X protocol to talk to the Windows System Server to do its operations. There's nothing magic about window managers at all. They're just another applications program. Applications themselves run obviously in their own processes, and any of these can be on any machine in your network, not just your local machine. So, for example, your application might be running on a compute server across the network, a large-scale multiprocessor, a Cray, whatever you wish, and your X server might be running on your 386 machine or your DeckStation or whatever other workstation you happen to use. So in X, applications are just clients of the Windows System Server. Some people find this slightly confusing in that they're used to the idea of their workstation being the client of other servers. Here we've turned things around. Your Windows system is a server to provide Windows System services to clients or applications running anywhere you like on your network. X was designed presuming toolkits. From our experience, toolkits are intimately bound up with applications as opposed to bound up in the Windows system. They're very much things that applications know about in fundamental ways. They're really essential. For example, without a toolkit, something as simple as a Hello World program would be of order 150 lines of C. With a toolkit, depending upon your favorite toolkit, it can be anywhere from a single line of code to 10 lines of code. I am not religious on which toolkit is better or worse. Use whichever one gets your job done. Unfortunately, toolkits themselves do show through into application structure. It would be desirable to be able to completely divorce user interfaces from applications, but it appears from most people's experience that it's possible only to a moderate extent, and there are certainly a substantial subset of applications for which those people building user interfaces are not satisfied with the compromises that are necessary to build a applications programming interface that is independent of Toolkit. There's clearly an interesting research area for lots of more work. I don't think we've seen the end of this, but certainly that seems to be the current state of research in the area. So if I go back to my slides here, if you have a typical application, there's the X library, which is just a simple library that encapsulates the X protocol and hides the bytes going on the wire to the X server. On top of that, you may have a toolkit to help your application. This is often structured into two pieces, one of which provides the base toolkit intrinsics, as it's often called, and then the user interface objects, in other words, what scroll bars look like, that sort of thing, are built on top of that. And your application may choose to use any of those levels for getting their work done. For example, for graphics, you typically want to go as close to the X protocol as possible. Most toolkits do not provide another layer on top, but have the application call the library directly for that work. Let's see. Before I go much further, I'd like to try to pull a little bit of this together. We've now talked about X being a network-based Windows system. I'll try to get you a feeling for this. You see 3 clocks on my screen here. This is sort of amusing. One of these is on the local machine. One of these is on on a remote machine, but in the same building. And the one that's 3 hours later is on my machine in Cambridge. I happen to be taping this in Palo Alto, California. So there's a 3-hour time difference, and you can see that on the clock. If we use this window manager here, it has what's called a virtual desktop. This is a window manager called TVTWM, and in fact, I'm going to look at my mail here. This application here is running across a wide area network to the East Coast, to the Cambridge Research Lab over a 56 kilobit network connection. And it's still usable despite the fact it's a shared link over a wide area network. So I could go look at my mail, that sort of thing. And of course, it's been a few days since I read my mail, so I have lots of new mail. And all the normal things behave normally, even though my application is running literally on the East Coast. Now, if we go back and look at a couple of instances on the West Coast, I'm using a program called DeckPresent for showing my slides. It's a what you see is what you get slide preparation program. On the other hand, I might also want to use a WYSIWYG system like DeckWrite. This particular program is running across the network to a DeckStation 3100 upstairs. It, as far as anybody can determine, behaves with identical to performance as if it were running locally. So this just gives you some idea that a user of a system can get extremely good performance across a local area network. So it, and of course so it does quite nicely. So an application running locally often actually will run, given 2 machines on a local area net, it's not unusual if those 2 machines are the same speed, for an application to actually run faster when running remotely than locally. After all, you've got 2 processors doing the same amount of work, and so that's not really an unusual circumstance at all. Okay, let me give you an idea of about window managers. I actually have a multiple screen display here for the purposes of my demo. I'll be using another screen that you folks can't see. And I will stop the window manager that I'm currently using and start up the Motif window manager. So let's see. Okay, I just stopped the window manager that I was using. And I'll start the motif window manager. Okay, and I started up the motif window manager. It provides a different style of user interface. It doesn't happen, at least I haven't told it to ignore the fact that my clocks are actually oval clocks. And it provides quite a different user interface. The icons, for example, are currently stacked up on the right-hand edge of the screen. And it has various kinds of menus to lower, raise, resize the screen, those sorts of things. This button will turn the window into an icon. And for resize, let me get the clock. I just grab a corner and resize. So it actually provides quite a different style of user interface than TWM does. You can use whichever style you feel most comfortable with. And I'll stop the motif window manager and restart the other window manager. So here's my clock again, and note again that how you resize is now changed again. This window manager doesn't always put a background on the window. This is actually an oval clock, for those of you who care. That sort of thing. Okay, so that should give you some idea of what I'm talking about. The window manager is just an everyday, well, it's not an everyday, it's a separate independent program. They're a little bit harder to write than most applications, but not terribly so. And it provides a lot of the user interface for manipulating windows. Okay, well, let's get back into the main line of the talk here, having given a quick demonstration of things. One of the major problems that one always has to face is what a system is going to be. There's always too much to do, and there's always too little time to do it in. So from our point of view, X version 11, we were very concerned about cleaning up our basic graphics capability, which had been inherited from a very early graphics display that Digital had made. We also wanted to provide the mechanisms for so-called decorating window managers and tiling window managers. So that was quite important to us, since we wanted the generality for the window managers. We'd also learned a lot about basic protocol design to make things run faster, that sort of thing. And equally important was some general extension mechanism, since it was pretty clear that the commercial pressures on X were such that further incompatible change was going to be impossible. So we were very concerned that X version 11 be extensible in a clean fashion, and I think we've succeeded quite well. For example, the round buttons and oval clocks that you may have noticed are things that have been added to X since the first release of X version 11. Equally important is understanding what a system isn't. It was pretty clear that it would take at least the people designing X version 11 at the time too long to do 3D, and we did not have the time to do it at that point in time. So we left three-dimensional graphics to an extension. Another major topic is various subpixel coordinate systems typified by things like PostScript. There are now things like display PostScript extensions to X, which provide that kind of capability. Protocol itself was designed for extensibility to allow these sorts of things to be added at a later date. Note that programmability of the Windows System Server is really only one form of extensibility. Most interesting extensions to the Windows system really require modifications to device-independent code. For example, no matter how hard you try, non-rectangular windows could not be added to X without modifying the device-independent code. Of course, it turned out, with 2020 hindsight, we should have put non-rectangular windows in X at the beginning, since it turned out to be very simple to implement. Keith Packard at the MIT X Consortium did his first implementation of non-rectangular windows in an afternoon. That's called 2020 hindsight. Sometimes you may think something is hard and it turns out not to be. Another very major issue that comes up in systems design are understanding problems. I think Phil Carlton made the statement that the only thing worse than generalizing from one example is generalizing from no examples at all. You have to fully understand problems before you can devise solutions for them. Problems tend to first manifest themselves and look quite different than they actually are. But when a problem does come up, it's very important to try to understand it fully and see if it really isn't just a symptom of a much more general problem. A good example in X is what happens to the window contents and sub-windows of an application when a window is resized. And that first showed up in X version 11 when we first started building more serious applications, and noticed that the bitmap editor really behaved poorly when resized. The program would first paint itself in the wrong position, then move all of its buttons someplace else. So in X version 11, to solve this particular problem, there's the concepts of bit and window gravity, which allows you to have the Windows System Server automatically reposition windows and bits inside of windows correctly when a window is resized. This cuts down on the visual flicker when applications are resized. Let's see, another major problem that comes up with dismaying regularity is that if you go ahead and solve a problem and your solution is poor, then that flawed mechanism to solve that problem, living with it is often very painful. It often inhibits trying to get the problem solved correctly. It's very often better to live without a facility until you really understand the problem. An example of this occurred. We initially tried to have in the X version 11 design specifications for how to handle dial and button boxes and all sorts of other different kinds of input devices. When we started implementing this code, we noticed that the design really was quite awkward. Trying to use it was going to be very difficult. And we basically decided partway through the, I guess, alpha tester that we'd just better plain remove that functionality from the core part of the X protocol, leave it to a later extension. And this extension to X to handle dial and button boxes and data gloves and your favorite kinds of input devices is basically pretty well completed. I think it's about to be declared a standard extension to X at this particular date. It turned out to be a much harder problem than we'd first realized. It's taken a number of years of working on it to get a decent solution for it. I'm very happy that we chose to remove that functionality from the original design. Well, when building a system, if you can get most of what you want for only a small fraction of the work that a solution to the most general problem would take, then you really should normally take it. You have to keep things simple. If you get your complexity merit badge, if you will, you've really failed. In X, we hope, and history I hope is bearing us out, that most of the complexity in X is actually for the benefit of window managers. where we can at least presume that a window manager is a reasonably expert X programmer. There's some additional complexity that's in the toolkits, and again, this is an area where most applications programmers don't work. So that we could presume that the facilities required to implement those sorts of things were things that only a toolkit writer would normally have to deal with. For example, in X, one of the interesting problems that comes up is what you might call mouse ahead. Applications don't necessarily respond instantaneously, and you'd really like, when you press on a button, that for example, press on a button and select a given operation, that even if the machine is slow for some reason, or your application is paged out, or any of a number of reasons, the application it may be busy for a short while, that the application get the right answer. And for example, know that even if I've well trained my fingers to press down and select 150% without even looking, that the Windows system get the right answer. So there are facilities in X to enable that. It happens to be called what's known as a passive grab. Most application writers don't have to deal with this at all. It's something that a toolkit writer has to be aware of. And Joel McCormick is smiling there because, of course, we didn't get it all right. But we got it mostly right, good enough for most people. Often, it turns out as you build a system that you learn along the way what's really necessary. In X version 10 and before, we'd accumulated a lot of sort of hacks in the X protocol to support information like what size windows should be, where they should be placed on startup, those sorts of things. It's often the case that a much simpler, more general mechanism can be used to replace a whole bevy of gross, unclean hacks to a system. And so in X version 11, for example, there's a set of mechanisms for storing typed information in the Windows system server, which replace all of these individual mechanisms that we had in X version 10. These same general facilities turn out to have been very useful since X version 11 has been out, and are often now being used in ways we just had no way to anticipate. The generality, it just turned out we were able to provide a much more general set of facilities that were also simpler, that also are now being used in ways we just could not have foreseen. That's when you know that parts of a system design are working well. Another major issue that you have to face, particularly in distributed systems design, is designing for failures. By which I mean, besides the joke that Murphy of Murphy's Law is out to get you, the Windows system server is fundamental to a user interacting with the machine. It's almost as frustrating as when your entire operating system crashes, when your X server crashes, since you'll lose all or most of the applications you're running. So you really have to be aware up front about how things will fail and design. So for example, in X, there's various semantics associated with applications dying. After all, they may be running on a different machine. That machine may crash, so that the Windows system server can clean up after a failing client. There's no way that you can rely upon a client to clean up after itself. So the most difficult problem that there's a fair amount of work that the server has to do, for example, is in resource allocation. It has to be able to clean up the resources after a failing client or a failing window manager, that sort of thing. So since clients can fail at any time due to either a network failure or client failure or a network partition, whatever, the server cleans up after each client connection closes. Equally, window manager failures really shouldn't take your entire window system down with you. You really would like to be able to change the window manager on the fly. For example, you might be customizing the window manager and need to restart it to make sure it's really doing everything correctly, or restart it after a failure. You don't want your entire system to go down when one piece of it runs wild and dies. That really is unacceptable. So you have to worry about those kinds of problems in systems design. Well, as in any system, there are always problems, and possibly the biggest one from my point of view is that experience shows that complete separation between function and the form, the presentation on the screen, doesn't appear to be possible. The look and feel of applications are split between the window manager and toolkits. You'd like the toolkits to also be plug replaceable. However, toolkits seem to be so bound up in applications that at least some people are not willing to make the compromises required to make toolkits plug replaceable. So it'd be nice if a single applications programmer's interface would work for different user interface styles, but reality seems to be harsher than this. So the result is you basically have to choose what style of user interface to at least some extent in your user community. At least in X, you can pick which one you want or make your own, versus a completely fixed system in which you either love what they give you or leave it. I think we succeeded reasonably well at our goals. Some people might argue our goals should have been different, but I judge myself by our own goals. We certainly did get a lot higher performance than we were able to get in X version 10. Some of the basic protocol overhead is about half of what it was before, that sort of thing. The graphics in X version 11 are considerably cleaner than X version 10. There's still some problems there in some of the new areas. The window manager facilities certainly have been used to build a very wide range of user interfaces. So I think we can say we succeeded. The window manager facilities. That X11 has been extensible in a reasonable way seems to have been well proven. Even things like oval clocks, which were not originally possible in X, are now being routinely used by applications. How much that's worth is a different question. Some people like those sort of things. I'm not going to argue with them. There actually are some very good uses for non-rectangular windows, though in this talk I don't have the time to go into them. Certainly, display PostScript has been added. There's 3D extensions to X of various sorts, double buffering extensions. So certainly, we seem to have succeeded reasonably well on making X extensible. Of course, there are problems in the design, mostly in areas that were new to X version 11. Some of the new functions for window management were not quite right. There's some papers that will be out in Software Practice and Experience shortly, which will go into some of the problems in this design. In the graphics area, we really should have implemented poly requests for all functions. This probably ought to be added as an extension because it allows for a large performance gain for certain kinds of graphics. There's some remaining problems in the definitions of graphics. If you in X draw a wide line, it uses a circular pen. It turns out that circular pens result in lumpy lines and arcs, which also use the same wide line semantics. There's some research that's been done since X version 11 came out by Hobby, which proposes various kinds of solutions where you can get aesthetically pleasing wide lines rather than lumpy wide lines, those sorts of things. I think arcs were a complete mistake. We probably should not have put them in at all and put in a general spline function instead. So overall, I'm reasonably happy with the way things have turned out. As in any system, we certainly are not perfect, but given our goals, we succeeded, I think, quite well. And I think that's the end of the talk. I'll entertain, I guess, some questions if anybody wants to ask such things.
Jim, a very simple one on our late slide. What's a poly-poly request?
Well, if you have a poly line, in other words, a connected line of line segments, you'd like to be able to have multiple of them together. Okay, there's a polytext request that gives you multiple text segments across on a line. The request probably should have been more general yet to allow you to have multiple of those encapsulated in one request. This reduces protocol overhead, and so there many requests are appropriately poly, but some are not, and we just missed the full generality that should have been there. Okay, Joel?
There seems to be a problem in designing these kind of things where if you have a small user community, you only run into a certain set of problems, and once you get a big user community, you find out about a lot of new problems, but all of a sudden you can't fix them anymore because there's 2 people that would have been affected.
Yeah.
For any of the kind of problems that you saw, do you think any of them were detected early enough and X has now become popular enough that it probably would have been better to fix those things?
Well, I think, as you said, there's a real problem of getting a large enough user community to uncover all the different problems. There were at least some problems that we detect that were detected during alpha and beta tests that at least one person didn't bother to mention to us that I really would have liked to have gotten fixed early on. But again, the real problem comes when you have something like X that achieves widespread acceptance so quickly, is that not all the problems are really discovered until it's too late to change to fix the problems. Some of these problems I think can be, actually most of the known problems in X can be fixed with either a protocol extension or an upward compatible protocol change, but until the standards committees finish doing their thing on the base current X protocol, I don't think anything will get changed. There are some areas where things are just not right, and we just didn't discover them until they're too late. And in fact, you were one of the authors of such a paper describing what can and cannot be fixed. So, yeah, Vasudev.
One problem that we're grappling with these days is the issue of dynamic extensions, and by that I mean programmability for the system on the fly. Rather than
right. The area where programmability in the Windows system server clearly has the most merit, at least in Bob's and my view, are on event handling. The requirements of applications are really quite complex, and the decisions being made are often need to happen before an application sees an event from the Windows system server. So you'd really like a way to be able to change the behavior of the Windows system server. The other uses of extensibility in the server have never struck us as particularly useful, but that one clearly has merit. From our point of view, something like a lightweight scheme of the order of what Joel Bartlett has done is probably the right way to have a clean extension mechanism or programmability extension to X. But yeah, there are areas in input handling where that kind of programmability I think very well could pay off. It's very hard to anticipate all possible needs.
Thank you. Another question is, when we first started working on X, we set ourselves a target for like 5-year time frame, a technology that we knew would be available within the next 5 years. Now we're hitting that boundary, and we're moving to the era of multimedia workstations.
Right. Well, as you can see here, I'm currently embodied inside of this window. The program running is a program of Lance Burke's here at the Systems Research Center, which is a normal X client. There's no smoke and mirrors here. There's no video extension to X. This is just grabbing the images and getting them onto the screen as fast as we can. So in another few weeks, we could add the audio as well across the network. The data itself is coming across the network in order to end up on the screen. And so as you can see, things like video, at least I believe, will end up just being an everyday X client application, though there may be hardware today that requires X extension. I don't believe that's true 5 years from now. So synchronization is a real issue. We have to deal with an X so that as you're replaying a set of recorded images, say off the disk, which will come in at a arbitrary rate, that the audio and video remains well synchronized. And Tim Glauert of Olivetti has a nice X extension for doing that kind of thing that I believe will be what's required for X to gracefully support this kind of an application.
I wanted to ask you, what's happening when a client uses extensions and the server doesn't offer them?
Well, I don't know any way around that. I mean, usually sometimes you're lucky and you can fall back to use other strategies, but if you depend upon an extension that isn't present, then your application won't be able to run. There are some extensions which are being adopted, if you will, with time into the core part of X, where it is expected that vendors should if they really want to be calling something X, should also provide a set of standard extensions. Okay, that kind of process is just beginning to happen. But certainly, if you depend upon an extension that doesn't happen to be in your local X server, then you have a problem.
When will you see that you have a problem? Is there any negotiation between the
Yes.
client and
a client?
the
A client asks the
server,
server, what extensions do you have, or please start this extension, and the server says, yes, I can, or no, I can't, and then it leaves it to the client to decide what to do in that circumstance. In the long term, we expect that the X consortium will start saying that particular extensions are a standard part of X now, and that all vendors should be providing these extensions in addition to the core protocol. I think that hasn't really happened quite yet, but it's not far from happening. And that was always the mechanism which we anticipated X would evolve. At this point in time, most vendors are beginning to provide some of the most common extensions. For example, the non-rectangular window extension that you saw, the so-called shape extension. And certainly within the next year, a client should be able to presume that exists on most or all servers. In fact, most toolkits that may want to give you oval buttons or that sort of thing will fall back to using rectangular windows if they can't find can't find the shape extension present. So that in that particular case, there is a fallback strategy that the toolkits can and do presume. Well, thanks again.